Very good morning to one and all present here. Today we are going to see about statistical quality control system and metrology. Before moving to the chapter 4, so we have completed nearly 3 chapters in metrology. So the basic fundamentals of measurements and what are the different types of measuring aids that are used to obtain the quantitative variable of an unknown dimension of an object. So the first 3 chapters, which describes about the calibration importance of metrological instruments and what are all the various possible way to maintain the accuracy and standards while doing the measurement process. Now today we are going to see the different extreme of the metrology and quality control. So the last 2 chapters, which discuss about the non-technical aspects, say managerial aspects of quality control in measuring instruments. The fourth chapter, which tells about the basic importance of quality control in manufacturing application. And here also we are going to see one numerical tool called statistical quality control system using X bar and R chart. In the meanwhile, we are going to discuss the quantitative aspects of X bar and R chart. Then sampling importance, what are the different types of quality sampling, how we can able to categorize the various types of sampling plan, a single sampling and double sampling plan. Then what is AQL, acceptance quality level. So these are the different the topics we are going to plan in unit 4. And in the last chapter, unit number 5, so the quality management techniques like failure mode, effective critical analysis, and Six Sigma error detection principle, how to reduce the error, how to detect and reduce the error in the product. So say Six Sigma principle, then root cause analysis. So this type of the quality measurement techniques will be discussed in the last chapter of metrology and quality control. Now we will go with the introduction to chapter number 4. So what exactly mean by quality control? So in manufacturing process, there are many components are produced at a different ability as per the compatibility of the machineries. After the final stage of manufacturing, so it is the duty of the engineer to assess the quality of the machined part. Without doing the quality testing, so the machine part cannot be taken to the next level of product assembly. So it is one of the most very important stage. Quality control and testing is one of the most important stage in the phase of manufacturing cycle. So each and every manufactured parts must undergo the quality check based on the report whether the part is free from defect or some minimum source of defects present in the manufactured part. If there is so something, then we have to repeat the entire manufacturing process right from the beginning till we attain the satisfiable results. So the quality control, which makes the manufacturing business to attain the ultimate the product quality to be improved in each and every part of the manufacturing stages. Another way we can say the quality control can be defined as checking the primary specification of the product. Say, for example, you are designing a shaft of 10 and length 250 whether the given part is able to match with the tolerable limit or not. If it is out of proportion value, then the given part need not to be accepted. It will be went under scrap or wastage. So in this way, the quality control can be better understood with a lot of simple examples. So next, we are going to compare the quality control system with quality improvement. So what do you mean by quality improvement? Quality improvement is nothing but showing some minor variation or little progress in whatever the day-to-day, the product service which we are supposed to do in our organization. Say here I can give some academic examples. Say if there are 35 students in a class writing semester exam, out of 35, say for example, 20 cleared in the first term test, that is periodical one exam. Uh, at, at the end of the outcome, we came to know that the students' quality has to be improved, enriched a lot. So as a faculty, we have to give some uh, as quality assignments or to enrich the knowledge, we have to take some additional class in the evening. So these are the remedial measures to improve the quality of the education process. So by showing some minor variation before and after the stage of the quality improvement process, then we can able to see how much wastage reduction we have taken effort to do that. Now with this few little introduction, now we will move on to the statistical quality control process. So what do you mean by statistical quality control? Say if I have 10 datas with me, I just want to check all the 10 number of datas whether it is workable or not. So I have to go by statistical comparison by plotting charts with the help of the graphical representation. So through graphical representations, I can able to confirm whether my all the information related to the product it is workable or not. So here there are two different methods in statistical quality control, acceptance sampling, and the other one is statistical process control. Let us see much detail in the following preceding slides. So first, let us go with acceptance sampling. So what do you mean by acceptance sampling? See here in this method, the whole the population of the part cannot be taken for inspection. Say for example, if there are 10,000 parts are there, out of that, a sample of 10 or 15, the parts are taken in random, and we can able to do the inspection process within that 10 number of samples. If the defective item is very minimal limited, then we can go for acceptance. If not, the rejection of part. So statistical process control, the next method in statistical quality control is nothing but statistical process control. So this method tries to use or apply the input of both sampling and statistical methods to observe the quality of ongoing existing production process in the shop floor level. After recording the existing process of the given production operation and making it as a graphical display by means of a control charts, say X bar and R chart. So that is one of the primary tool in variable chart. So using those control charts, we can able to claim whether the proposed manufacturing model behaves within the safe control limit or not. So the first few slides we have just introduced about what is meant by quality control. What are the different types of the tools, models used in quality control system? Now, in much detail, we are going to see what are the major tools of quality. So these tools are used for descriptive statistics, say histogram, Pareto chart, cause and effect diagram, check check sheet, scatter diagram, control charts. So these are the tools that are used for uh, descriptive mode of statistical analysis. So before moving to subjective mode of discussion, let us have some basic insights on different classification of statistical models. So there are two different types: descriptive statistics and inferential statistics. What are those two types of statistics? So the first one, descriptive statistics. Say, for example, when you have a bunch of data or a huge population of data, so those things can be pictorially represented by means of a bar diagram or a pie chart. So through from that, we can able to draw the conclusion what is what. Inferential statistics is considered to be a pure numerical method of statistical analysis. Say, in mathematics, you have heard about t-test, f-test, etc. So using that, we can able to take a random sample and we can able to fix the significant level of acceptance, that is alpha, referring to the tabulated value. We can able to compare the theoretical and experimental value, and based on that, we can able to fix the null hypothesis, whether it is accepted or rejected. This is relevant to inferential statistical method. And these are some of the few categories in statistical quality control, three broad categories. So the descriptive statistics strongly believes on the basic principle of mean, median, mode, standard deviation, and variance. So next thing, statistical the process control, which tells about the final output or final state of the product by inspecting individually each and every product. And we can able to measure the quality characteristics by charting down all the data with the graphical format. And that will help us to identify whether the process is within the tight control or not. The third one is acceptance sampling. So it is a random sampling plan which we can able to aim for good or bad path depending on the random selection of the sample size. So let us have a few introduction about the concept, how to calculate the mean for the different set of sample. Say for example, I have 10 different type of machine shafts with varying diameter. So I need to find out the mean sample of all the components by taking average of those 10 samples. This is a formula which is used for defining the mean of the sample observation, and especially standard deviation. So from the mean, we can able to find out standard deviation by taking square root. And also we can find out how much variation between each sample. That also we can able to assess by fitting the confidence error interval of each sample size. So with this few introduction, I end today's lecture. So in the next class, we will begin with further the continuity related to the quality control system, variation in quality, and other allied topics related to quality control. So thank you, one and all.